So right now we're on the back of your phase change sheet where we have a little bit of practice that we're gonna do. So what we're gonna do here is we are gonna first of all take a look at the chart with the different processes, the different phase changes. And we're gonna say, are they going from a solid to a liquid to a gas, and then decide is the amount of energy gained or lost by that process. And this provides us with a good review. The first one you notice has been done for you. Deposition, which you may not be as familiar with, is the phase change in which water goes directly from a gas to a solid without passing through the liquid stage. And this is what happens when we get frost forming in really cold weather. The water vapor which is in the air will turn directly into an ice crystal and become a solid. And to do that, the water has to lose energy. The molecules have to slow down to become that ice crystal. Sublimation is the opposite of deposition. Sublimation is basically how we get snow to disappear even when it's below freezing, or for glaciers, to lose their ice even though the temperatures are below freezing. And this is when we end up with a solid, in this case ice, turning directly to a gas. It's similar to evaporation, except you skip the liquid phase. And to do that, that ice has to gain energy, typically from the sun striking it and warming it up. So let's go through, and I'd like you guys at this point to pause the video and see if you can do melting, freezing, evaporation, and condensation on your own, and then unpause the video and we'll check out the answers. All right, so for melting, hopefully you said this is the process where water goes from a solid, if we're talking about water, it's going to be ice, to a liquid. And to do this, that object would have to heat up, so it would have to gain energy. The water would have to gain energy in order for that to happen. Now, freezing, of course, is the opposite of melting. This is when we go from a liquid to a solid. And of course, for that to happen, the water has to lose energy. The molecules have to slow down. So we're going to say energy is lost, or you could say it's released into the atmosphere. Now for evaporation, another word for evaporation is vaporization. Boiling is similar to that. So evaporation and vaporization are the two terms that we're going to be using. This is when water goes from a liquid to a gas. And we talked about that process with the water cycle. We use the term evapotranspiration. And to go from a liquid to a gas, that water has to gain energy, has to heat up. Again, typically from the sun when we're talking about weather. And condensation, the opposite of evaporation, is when water goes from a gas to a liquid. This is the process that forms all the water droplets that create our clouds. And to do that, energy is lost or released during the process. So that was a good little review of the phase changes and whether energy is gained or lost. Now what we want to do is show you specifically how much energy is being gained or lost. So I want to know, how much energy would it take to melt a 50-gram block of ice? Well, in order to do that, I have to figure out how much energy is involved in melting. So I go to my reference tables, my properties of water column, and melting, the water is going to have to gain 334 joules for every gram. Well, I have 50 grams, so in order to figure this out here, I'm going to have to do 50 grams, and I'm going to multiply it by the 334 joules per gram that I get from the reference tables. And when you do that, kind of not giving myself a lot of space here, put it in your calculator, the grams reduce, so they're gone, and you're going to get 16,700, getting a little sloppy here, 700 joules of energy is what it needs to melt that 50-gram block of ice. So the next question then is, how much energy would it take to evaporate 50 grams of liquid water? So notice the mass is the same, but the energy involved is going to be different. So pause the video, give it a shot on your own, and then unpause when you're ready, and we'll go ahead and check this out. All right, so the way I'm going to start this out, I'm going to start with the same 50 grams, except this time when I multiply it, I'm going to multiply it by the energy required to evaporate or vaporize the water, which is 2,260 joules per gram. So 2,260 joules per gram. And when you do the math on this one, you're going to get a pretty big number, 113,000 joules of heat energy is required to evaporate 50 grams of liquid water. So then our final question says, does it take more energy to melt 50 grams of ice or to evaporate 50 grams of water? Well, the answer is it takes a lot more energy to evaporate the 50 grams of water. If you think about it, that makes sense. If you take an ice cube and just put it on the ground in a normal classroom, it's going to melt pretty quickly. But it would take a lot longer for that water to evaporate. And again, that's because it just takes so much more energy for the water to evaporate. So that's how we would do it if they ever asked you how much energy is involved in one of these phase changes. Next thing we're going to do as a group is start taking a look at dew point and relative humidity, which allows us to assess how much moisture there is in the atmosphere.